Oh, hello everyone. It's very late, so I think I'm just gonna do this and then call it a day. ARU cache. Design ARU cache. The least recently used. Let's initialize with positive size. Okay. Get, return the value of the key if key exists, otherwise -1. Put, update the value of key if key exists, otherwise add the key value pair to the cache. If the number of keys exists, the capacity. Evict the least recently used key. Okay. If I remember correctly, I think this is linked list. If I remember correctly, I'm not 100% sure. One of them was, I remember it's linked list, right? So we'll put, so we have a dummy here. Okay, so we put, we'll have key and value. Let's say key value, right? And then we put, let's do this, key value. So capacity is 2, okay? Capacity is 2, right? So key value put 1 and 1, and then we put 2 and 2, and then we get 1, so we get 1, and then we put 3, 3, right? So we need to put 3, 3. So, but we cannot put right now. Then we need to remove something. So this is the least used. So this one gets removed. Then we put 3, 3 in. Then we get to, oh, holy crap. That's not right. Dude, that's not right. All right, let me do this one more time. We put, and then we get, right? When we get this, we find what it is, we remove this, put it to the end. Okay? So now, this is the thing. Now we want to put 3, but we have a capacity, so we remove this at the front, right? And now we put 3, 3 in. And now we try to get 2, 2 is out, so 2 is -1. Now we put 4, then we'll remove this, right? Then we get 4, 4 in. We get 1 is out, 3 is 3, 4 is 4. Yep, I think this is linked list. I remember the first time I do this, probably we were thinking about what was I thinking about? Priority queue, right? Probably priority queue. But this, we're gonna do a linked list. So we do need a list node. I mean, geez, list node will be very basic. I mean, I don't even need a value. Do I even need value for list node? I'll have a dictionary to keep this. Dictionary keep key, right? Yeah, I can do key value, or just the value. This is the value, okay? Key connects to the the address, right? So every time we do this, we'll put this. So in the front, we can find. But what if you want to know the key? That's fine. That's fine. And we want to remove. Yeah, let's do key value. That's fine. That's okay. That's okay. Self. We need key. We need value. Okay. Self.key equals key. Self.value equal to value. Okay, self.next equal to none. That's it. That's just that. Okay. Self.cap equal to capacity. Self dot mapping node map self.dummy. We probably need a head and a tail. Okay. Initially, head and tail pointing the same thing. Okay, get. We want to get something. So we shall return if key is in self.node map. Then we shall return self.node map key dot value. Right? But before doing that, we need to move this. So we have a def move and pop front. So move to end, okay. Don't return anything. So we move to the end. Basically, we will need the node, right? We need a node to move to the end. Oh, double linked list. Oh my god. Pre and next. Previous next. Prev. Yeah, we need a double linked list. Doubly linked list. Then we don't even need move to end. That's it. We don't, yeah, that's it. So we have a node, we need previous and the next. So we need his, oh my goodness, node dot prev dot next equals node dot next. Okay, node dot next dot prev equals node dot prev. Right, now node gets out. Then self dot tail dot next equals node dot pre equals self dot tail node dot next equals none. Let's move to the end. Move something to the end. So then we have pop front. So how do we pop? Self dot head front equals self dot head dot next. Right? So self dot head dot next shall equal to front dot next. Okay. Self dot no, front dot next dot prev equals self dot head. So head dot next, and this dot pre. That's it. We basically pop the front. I say front dot next equals front dot prev equals none. So that's we pop it. So if key is in this, then we say self dot move to end. We want a node, so self dot node map key, right? We move this to the end, make sure we have used it before, have used it. Otherwise, we'll return -1. Put. Now we want to put if key in self dot node map, then self dot node map key dot val equals to value, and then we'll move this to the end. Else it's not. What if it is capacity? Evict the least recently, so else depends. So elif lan self.node map. If it's smaller than self.capacity, then we can just add this. Doesn't matter, we just add this. Then we just say self.tail. Oh, pop front, append and. I just say append. We'll append the node. We have to do this node. Key equals key, val equals val value, right? The other all become none. So we'll append it and then done. Oh no, yes, done. Else get move to end, put if key in it. Okay, we change it. If it's smaller the capacity, now we need to pop. So else, which means this is already equal to capacity, then we need to pop. Oh, we need to return the list node that gets popped. Return front. Okay. So we say popped node equal to self dot pop front, right? We pop front. Oh, what we can do else if lan self dot node map is equal to self dot cap, then we'll pop it, right? We'll pop the node and we'll delete self dot node map popped node dot key. We'll delete this key, right? After that, we'll append it and new node equal to this, right? New node and self dot node map key equals to new node. Oh, we need to assign move to end. Self.next equals node, and then self.tail equals node. Pre the next equals node of pre self.tail the next node. Wait, move to end. That doesn't make any sense. Oh, that does make sense. You'll move this to the end, and then we set the tail to this. Pop front, nothing needs to change. Append, we have to set the tail as well. Right? They all have to set. And then here, new node. We actually don't need new node because I can do this. Or append a new node, and this actually equal to self dot tail. Okay, let's give this a shot. Does that make sense? Follows default argument. Oh, sorry. Yeah. Alright, I think we have an error. None type has no pre. We have a none type. Oh, I think I set it up wrong. Sorry. Tail. Yeah. And then self.head.next equals self.tail. Self.tail.pre equals self.head. So these two don't move. Okay? These two do not move. Then when you move to the end, right? When you move to the end, you basically just get in between the tail and the previous of the tail, which is, you know, easy enough. So we'll remove that, right? The prev.next, next the prev, and then here it's not right. This is gonna be, of course, this is also not right. Oh my god, I have so many errors. Tail.pre, right? .next equal to node, and node dot pre shall equal to self dot tail dot pre, right? Node dot pre self dot tail dot pre, and self dot tail dot pre dot next equals to node, and then node dot next shall equal to self dot tail, right? And then self dot tail dot pre shall equal to node. None of these is necessary. Pop. There's no head. There's a head. So this is still take the head out. Return pop. That's fine. This shall be append. Oh, I can actually call this. Hold on. Put this one here. This actually need to redo it. Right. It's this. That's append. Append a node. Node.pre equal to this pre. Tail.pre dot next will equal to node. Node.next equal to tail. Tail.pre equal to node. Okay, that's, so this will be self.append, right? Or append node. I can just do pop. Right? It's just a pop. Pop a node. Right? Now we just, that's gonna be node. And node dot pre equals self. We just pop a node. This is sufficient. Pop a node. Right? And we set this, right, pop a node. We don't need to return anything because we already know it's gonna pop. So we pop a node. Then we do this. So here, move to the end will be self.pop node, right? We pop the node out, and then we append the node at the end. That makes more sense, right? That makes more sense. So if key is in, then we will move to the end. We'll move this to the end, and then we'll return this value. Done. Otherwise, for put, if key is in, we will update move to the end. Otherwise, if this is this, then we need to pop. All right? So popped node shall equal to self, no, shall equal to, yes, self dot head dot next. Okay? Then we will pop it, and then delete it. And then I will append the new one and do this. All right, let's see if this one's right. Just these little errors. Come on. I haven't eaten yet. None type has no pre. How is that possible? Oh yeah, one of them was not right. Let's do it again. Append node.pre equals self.tail.pre. Self node.pre equals self.tail.pre. Okay? And self.tail.pre.next equal to node. Okay? Node.next equals to tail. Self.tail. This feels good. This feels right. Pop. We'll pop node. And node.pre .next equals node.next. Node.next, pre.next. I'm popping this, right? So node.next is whatever is node.next. So pre.next and node.next. The pre equals node.pre. That looks good as well. So the pop looks fine. Move to the end will be, we'll pop this and we'll append it. They all look right, honestly. I don't know. Get. If key is in this, we'll move to end. Makes sense. And then return the value otherwise, okay? Put. If key is in it, I update it and then move it to the end. Otherwise, we check the capacity. Right, if the capacity is filled, then we have to delete the one right next to head. Right, we find this and then we'll pop it. And we delete its key. And then I'll append the new one. Oh, that's not tail. Yep. Tail.pre. A little error. Yep. Slight error. One, 4, 6. Use doubly linked list. Oh. All right, let's take a look at the previous one. What was my previous solutions? Error, error, error. What was I trying? 22. I use a deck. I have a counter to count. And now I return a cache. Or append. Cache. If too much. While this is larger than 1. Self.counter. I think the counter is the count number of times, right? If it's larger than 1. LRU. What do I append? 0. LRU 0 is the key, right? If this count is the key is larger than 1, I'll pop it, and this one minus equal 1. Huh. Wait, what is the counter again? Actually, I don't know. How was I trying to do this? Yeah, I use this, so I have the counter. LRU.append key. Okay. Cache. So most recent use is always on the right hand side, right? So the left hand side will be the old one. So I say counter. If it's larger than 1. Oh, I know what this is. If it's larger than 1, that means I have used it before. That's multiple usage. If I have multiple usage, that means if you're on the front of the deck, it must be, and there must be a most recent use on the right hand side, so you can just pop them. You can pop all of them. Okay, I see what I was doing there. Makes sense. This is the doubly linked list. Remove, add, move to, I say move to head. That's the same idea. Get, yep, 22 test cases. This is 22 test cases. I'm not sure why this one's so slow. Well, there are a little bit more involved. Add, remove. I don't know. It looks pretty good today. Huh? Yeah, that's pretty good today. All right, so nothing more to see. It's linked list, very straightforward. I mean, this one also works. Yeah, this one also works. All right, so we're done. Yeah, let's just do one. Let's do one. Find a distinct difference array. You're given a zero-indexed array nums of length n. A distinct difference array is an array diff of length n such that diff I is equal to the number of distinct elements in the suffix I plus 1, so to the right hand side. Subtract from the number of distinct elements in the prefix. Return the distinct difference array. Note denotes the number starting I and j inclusive. If I is larger than j, then denotes the empty. Okay, so the number of distinct elements in the suffix subtracted from. So from here, index 0, there's one element in the prefix. Oh, because I didn't include this. Okay, one element, 4 elements. So 1 minus 4, 2 minus 3, 3 minus 2, 4 minus 1, and 5 minus 0. All right. So basically, we're just gonna keep adding on the left hand side and keep removing on the right hand side. Distinct. So a set, right? So a set. Let's do a set. How would you do this? I'll say a left set, right set. Can we do it easier? What do you think? Nah, I think set. L set. ls rs equal to set and set nums. Actually, it's not set nums. It's set nums 1 towards the end. Right? Then we say for I range len nums, maybe for n in nums, this dot add n, res is this, right? Res dot append len ls minus len rs. Maybe that's actually a better way. This rs dot remove n. We cannot do that. Because if we have repeats, do we need counter then? Counter. So ls plus equal 1 n minus equal 1. If not rsn, delete rsn. Then we do this, return res. All right. Okay, looks promising. Nothing to say about this. Alright, I'm gonna stop here because I really have to eat. I have to finish a bunch of stuff. So I'll see you guys tomorrow. Adios.